Okay, good afternoon, everyone. Welcome back to the first day of Gravitational Waves Open Data Workshop, number 7. And I hope you had a good lunch because from now we are going to have the hands-on session. So let me introduce to you some of the basic things and some of the announcements during the hands-on session. Starting today, we are going to have 3 hands-on sessions over the next 2 days. And during these hands-on sessions, there will be mentors around you to help you to run all your codes. And for the on-site participants, it's great if you can just directly raise your hand and communicate with the mentors around if you have any difficulties. For the online participants, it would be great if you can post your issues on the Q&A box or on the chat, or moreover, as Jonah mentioned in his talk, you can post your more detailed queries on the ask.iguan.org. That would be great. So if you go back to your registration page of the Gravitational Wave Data Workshop, you can see there is a link provided under the name of tutorials in the GitHub. So if you click that link on the GitHub, you will be redirected to this page where you will find that you have something called challenge, tutorials, and other stuff over there. So we would recommend you to click on the tutorials folder, and the moment you click on the tutorials folder, you will be coming across the 3 days tutorial that we are going to use to introduce the different aspects of the gravitational wave science. Suppose you have clicked on the day 1, which is definitely today, you will be directed to this IPUINB files or the Jupyter Notebook files folder. Now, we would recommend you to use the Colab one. You can click on the Colab link, or even if you prefer to use My Binder, that's also is up to you. So you have to click on the Colab button, and then that will be redirecting you to this notebook, where you will be finding that there are the different files or the different scripts that we're going to use today. If you click on one of the first listed script, you will find that it redirects you to this open page where it's written the Gravitational Wave Open Data Workshop number 7, and you can see there you have something of software installation and other things. Now this is a Google Colab, so a Colab notebook, that means you are doing it on your drive and you don't need to do anything in your local system, which actually benefits the burden of installing stuff in your local system. So you can just press Shift and Enter, or you can just click on that green button to execute your code. And as you execute your code, you will get some of the outputs, and in the different cells, you will get some of your outputs from here. And during this stage, if any one of you, both online and on-site, have any issues with something is not working or you are getting some error, please do not hesitate to get in touch with us. We'll be very happy to guide you through and help you through. And after that, you can also go to the day 2 and the day 3 workshop that we are going to have tomorrow and day after tomorrow. Both these folders have the similar Jupyter notebooks, and you can also click on the Google Colab to redirect you to run all the scripts thereafter. And after that, when we finish our day 3, there is a folder at the top of the GitHub link, which is called challenge. And if you go to those challenge, you can see that there are certain tasks that are given to you, which you can complete and submit your answer. There is another good thing is that at the end of each data workshop folder, if you scroll down below, you have some very small tasks given to you, which you can finish it up here or you can finish it later. So with this, we would like to start our hands-on session. Most importantly, if something goes wrong, please do not panic. We are there to help you out with any kind of things, and feel free to ask any questions, because we, the local organizers, want to have it a more interactive session than a one-way channel. And with that, I would like to hand over the session to Takahiro Yamamoto-san to explain more details on the hands-on things. Thank you very much.
Okay, so let me talk about the hands-on session of the continuous wave. So from this thinkweek.com, you will find the continuous gravitational wave of different origins. One continuous gravitational wave, and here's a tutorial A.3. Okay, and so in this hands-on session, we use the module Python package PyFstat to make simulated data and carry out search and parameter estimation by F statistic, and using half, which can perform half transformation to search the continuous wave. And so, I have prepared 3 notebooks. So I show you that how to download it and how to use it. So please click this link to shared Google Drive, and then you will find these shared files. And first 3 are the Python notebooks. First, you generate data, and second, you generate by using these generated data, you search the continuous wave by F statistic. And in the last notebook, you will use half transform to search the signal. And there are 2 PDF files. First one is answer to the question, which are in this tutorial notebook. And the second PDF is instruction to start this tutorial. So I prepare it, and so here's a list of materials, how to copy the materials to your Google Drive or something. I will explain later. And this tutorial _utils.py is a Python script to plot the figures much easier. So after clicking this link, what you do is that, unfortunately, Google Drive will not provide the function to copy the directory to your Google Drive. So you push here. Okay, so it is. Sorry for this. Is written in Japanese. So I'll say here, so click here, and you will see the download, and click download, and then you will a zip file is saved at your local computer, and unzip this zip file. Okay, so let me try. So click here and download. Yeah, you can see this icon. Yeah, push download, and then the system prepare for downloading, and then download start and complete. And going to the your local download folder, you will see here zip file, and double click here, then you will get materials here, and then you move to directory My Drive, and then drag and drop to your My Drive directory. So be careful. So if you drag and drop this zip file, your computer will upload the zip file. So and it's not easy to unzip that. So please take care. You drag and drop this this folder, not the zip file. Anyway, so the upload is completed, and double click this download uploaded directory. You will see the you completed to copy the materials. Okay, so and let's start from the first notebook. Click the third, click the three dot button, and open with Google Collaboratory. If you don't find Google Collaboratory here, then you need to connect service from here. And yeah, okay, if you click the plus button here, then you will see the Google Workspace Marketplace, and you can search application and you by Google and then you find the application here. So just a click. So yeah, I already installed, so this shows uninstall button. But if you have not installed the Collaboratory, install button here. So just a click install. But anyway, so to open notebook here, click three dot button, open with Google Collaboratory. Okay. So, okay. So first notebook is for the generating data by using a PyFstat. So what you will do first is installing the PyFstat to your Google Colab, and okay, press drag button here, and then it takes a bit time to install the PyFstat. Okay, so this so Google Colab have already installed the common used library, NumPy or something, and that pre-installed version is not fit to the requirement to the PyFstat. So this command will reinstall the NumPy. So it will take a time, and after complete the installation of NumPy, you need to restart the session. But you just follow this pop-up. Yeah, it says that you need to restart the session. Okay, and just press restart the session. Okay, so, and you don't need to push this install command again, and we go to next command. Yeah, so next is that mount your Google Drive directory on this notebook. So after running this command, you can this notebook can access to the your Google Drive. So just press triangle or press Shift and enter, and you just follow the instruction of this pop-up page, and you know, yeah, you just follow the pop-up page, and at the end of this last line of this command, it will show the contents of this directory. Okay, you see that yeah, 3 notebooks and 2 PDFs and 1 script. Okay, so here's you import the module to use these modules for in this notebook. Okay, so all right. So okay, so let me switch another account. So please wait for a moment. Okay, so yes, yeah, I don't want. Okay, so it's loading. Okay, so you have installed the data and okay, sorry for that. Yeah, sorry, I have generated a figure or the materials, but in advance, but I lost them. But anyway, so notebook still here. So let me start from the beginning. The install py-f-stat. Waiting for a minute. Okay, so importing the libraries like NumPy, py-f-stat, or this tutorial underscore utils is for the script to plot figure easier. Okay, so let's start from we start from setup writer instances. So you provide the label to specify the description of the data. Here we will generate the single detector Gaussian noise data, and here the dir specifies the output, the name of output directory. So all generated data will be saved under this output directory. And this, okay, and various parameters should be provided. Here we will make 5 days data. Here we generate a set of short Fourier transformed data with 5 days duration. 5 days duration at 100 hertz with a frequency band of 1 hertz. And SFT length is 1,800 seconds. Okay, and just shift one, click the shift plus enter. Then this writer dot make data creates a SFT data, and you can check directly from your Google Drive. You see that here the directory, and with the pattern, here's generated data of SFT data. Okay, so and yeah, in these three blocks is for the checking. So okay, to read the data from the files, you specify the file path to the SFT, and it is stored in this writer.sft file path, and you just use get SFT as arrays. Then you will get Fourier transform data as a NumPy array. Okay, and these arrays have shape of 1,800 times 240. Okay. The first is the number of SFTs segments, and the second number shows the number of frequency bins. And here we use tutorial underscore utils to plot the data, and okay, so it's a bit large figure, but anyway, so this plot shows real part of SFT and imaginary part of SFT. So here we do not inject any signals, so you don't see any signals here. It's just a random Gaussian noise. And here, so, and as following we check that this is actually follows the Gaussian distribution. So, okay, so this is basically how to make generate the data. And the second task is that inject signal. Here we will inject signal with its parameters. Frequency is 100 Hertz, and with spin down rate as 10 to minus 9 Hertz per second. And here the sky position and amplitude, and here. And so you will need, in the first step, you just provide the levels or the duration. But here, you need to also provide the signal parameters like this. Yeah, okay. Here, the signal parameters are fixed and provided. And if zero gravitational frequency is 100 Hertz, and first derivative of frequency is 10 to minus 9 Hertz per second, and so on, so on. Okay, so just, and if you run this code, sorry, and okay, I will stop. It takes 3 or 4 minutes because that we set here the duration is 1 year data. So it takes, okay. And you will, and after generation of data, you can load that data by using get SFT as arrays. And you can check that how the signal look like, and by this plot, by running this code. But here I stopped the generating the data, so I will not show. And the last thing is that create a mock data, which will be used for the second and third. Yeah, so F statistic and frequency half. And here's already provided parameters here. So, and here you will generate 0.4 year SFT data, and you will, yeah, and as a, you will generate data. And after running this block, you will find your directory. In your directory, you find a new folder named mock data, and it contains forget about upper two folders. You will find this. Okay, so SFT data. So in the F transform and pi half, you will use this data. Okay. So basically, this is all of the first notebook, and you can play with several options with injecting non-Gaussian noise or assuming that there is gaps in detector data. Oh, sorry.
Yeah, first of all, I'm interested in what sampling rate it's going on, it's using, and also when we generate the Fourier data, the Fourier data, its shape is 1,800 and 240. I'm not sure that's cell number 8. Yeah, sorry for not mentioning accurate enough.
This one? So, yeah, so.
Yeah. What sampling we are doing on?
Here
Or
we
it's not?
just create SFT data directly, so we don't create time we don't start from the time domain data. Just pi f start writer create SFT data.
Oh.
Okay, so assuming that, yeah.
Okay, thank you. Yeah, I got it. Yeah, next question.
Well, I guess my question is, okay, so that was a really great introduction, thank you. So we've got two different sort of sets of tutorials that were introduced. So I guess my question is, where do we want students to start, and how do they get going here?
That's a great question. So the students can start from the day one tutorial, and we are here both on site and to help out the online people if they have any issues. And after they have completed the day one tutorial, they can move to this one, because this is a bit more specialized, and the day one tutorial is the very basic introduction and the generalized format. Yeah. Yeah. Oh, that's fine. Yeah, that's fine. Yeah, but when the participants can also start from day one. Yeah, day one, because those are more basic ones to get introduced to GWs. Okay. People, if you have any questions, we are here to help you out. So can the mentors just raise their badge to show they are available for help? And online people, please feel free to send any questions on the chat. And also, we have linked the Google Drive for this current for this continuous wave background tutorials in the chat.
Quickly move to the second and the third notebook again. Yeah. So I can quickly go through these second and third notebooks. Yeah, here the second notebook is for the searching continuous wave by F statistic, and yeah, you just okay. So again, you install the PyFstat and something, and mounting the drive, and okay, do I need to? Okay, so I will follow the what the notebook will do. So first, we will search the signal with fixing the all parameter except for the F0, the frequency at the initial time, at the reference time. So and then next we move to the searching over the F0 and the F1 spin down. I'll do it, and so again, you install the PyFstat module. And mounting your drive on this notebook, and importing the libraries. Good. So after importing libraries here, and then you start searching over F0 frequency at the reference time. So labels providing here, and this block defines the directory for where the result will be saved. And next one is just specifies parameters which are used for the injection. And important point is that if you already generated the SFT data, so you put the file path to the .sft data. Okay. Yeah, this variable is used for later, and yeah, here's the important point of this PyFstat search. You define the grid and run search. It will take 3 or 4 minutes, so here's these 3 lines are the grid parameters. Ngrid is the number of grid points, and df0 is a grid width between the neighboring grids in F0, and delta F0 is a range of F0 to be searched. And following these 5 lines defines these five variables will be the arguments of the function pifstat.grid search. So if you provide 3 values, they will search over these parameters. And if you provide only single value, then this module will be fixed parameters.
Yeah, maybe they can start with day 1 and then
Too much.
move through this tutorial. Yeah, because I think these are in the Google Drive, and they also need to upload this to their Google Drive and try the following. Yeah.
Yeah, that's very good. Let's let them try it.
Yeah. Okay. Yeah. Thank you.
Yeah, sorry about that.
So online participants and on-site participants, you can start with your day 1 session. And if you have any difficulty, just let us know. Yeah.